Hello everyone, welcome back again. This is the continuation of the one-way ANOVA that we have just conducted. Now, in our previous video, we noticed that our results or our output was statistically significant. Let me go to the output, which require further tests. And now we also notice that the assumption of variance with the Leibniz statistic, the assumption of variance is met. So we need a further test, and the further test we have to do is we use the Tukey HSD. So how do we do it? We go to analyze, the same compare means, and then the one-way ANOVA. Then we put our score as usual to the dependent list, and then our ages to the factor. And then now we come to the post-hoc, and then we choose our Tukey. So now since it is equal variance assumed, we can choose any of these one can work, but let's select the Tukey. And if it is not, if equal variance is not assumed, we can choose any of these ones. So in our case, it is assumed, so we choose this one from within this group, and then we choose this Tukey, and then we continue. Now we have to also come and then select descriptive statistics or descriptive, so that we can see the actual means ourselves. Now we say okay. So now when we run the test, this one is already in our first video, so we don't need it again. This one is indicating that there is differences, but it did not reveal where the difference is. And now we have our mean scores across the age groups. Those within age group, or those under 20 years age group, have their mean score as approximately 60%. Those within the age group 20 to 29 years have their mean score approximately 73%. Those within 30 to 39 have their mean score approximately 79%. And then these people too, those within the age group 40 to 49, also have theirs approximately 70%. So now this one will just describe what we are seeing, or we are just describing what is happening. Now this one here, multiple comparative analysis, that is using the Tukey HSD. So it will pick any of the age groups to compare it. So what you do is you see those under 20 years, you compare it with 20 to 29, and then you check the significance value here. This one is less than 0.05. That means this particular one is statistically lower. You know, they perform lower than this particular group. Those under 20 years perform lower than 20 to 29, and then it is statistically significant. So which means those within 20 to 29 can perform better. Not just by random, but they can do. And then comparing the same 20 to 39, and then we check the significance value. Comparing 20 to 49, we check the significance value. So under 20, those under 20 are significant with the other age groups except 40 to 49, because this one here, the p-value is greater than 0.05, because this one is 0.334. And then you pick this one too, and then compare it the same way. So that is basically how we do the further test. So here it is revealing where the differences lies. So let's see how we report this one in Word. Now we just finished. This is a complete report. So this is the first part, our ANOVA, and then this second part. So we now want to dig deep into to get where the differences lies. These are the descriptives as I just explained to you in the outputs. And now we have our differences. So you have to redraw the table. So those under 20, so less than 20 years, and then we compare it to this group. And then we take 20 to 29 years, and then we compare it to 39, and then 30 to 39, then 40 to 49. Then 30 to 39, compare it to 40 to 49. So that means we have exhausted the comparison. Then you match it with this particular value, this particular side. Let me put all borders so that this particular area, you can see it here. Though in academic form, you don't have to do it what I just did. It should just be this way. But I just want you to see the clarity so that to show you, and those within here are those we use to confirm. So when you check, you could see that we have those under 20 and then 40 to 49, there is no significant difference. And then those 20 to 29 and 40 to 49, no significant difference. And then 30 to 39 to 40 to 49, no statistical significance difference, because 0.053 is greater than 0.05. So now these are the things you emphasize here. So let's see how we report them. Table 7 presents descriptive statistics for score categorized by age groups. The results indicate a distinct upward trend in mean score from the youngest to the middle age groups. Individuals under 20 years of age exhibit the lowest mean score, and then we just indicated, whilst those aged 30 to 39 years demonstrated the greatest mean score. Individuals within the age group 20 to 29 years and 40 to 49 years exhibited intermediate mean score of this respectively. This and that respectively. That means those within 20 to 29 have this one, and then 40 to 49 also have this one. Now subsequent, so this is where our interest lies. Subsequent to the statistical significance one-way ANOVA. So this one is a follow-up to this table. This table, that's what we are trying to see. Post-Hoc multiple comparisons were executed utilizing the Tukey HSD test to ascertain whether specific age groups exhibited significant difference in their mean score. Table 8 illustrated that respondents under 20 years of age scored markedly lower than those in 20 to 29 years, and then this is the p-value, and then 30 to 39 years age group bracket. No significant difference from this particular age group, 40 to 49 years. Subsequent comparison revealed that participants aged 20 to 29 years exhibited markedly lower mean score than those age group. So this one here, that is showing statistical significant difference between this group and then that group. No substantial differences were seen between the age group 20 to 29 years and then 40 to 49 years, because this one is greater than 0.05. Respondent aged 30 to 39 years had higher mean score compared to those 40 to 49 years. However, the difference was not statistically significant because this one is also greater than 0.05. So now, the post-hoc data indicates that statistically significant score variation were predominantly linked to age progression, with younger respondents displaying lower score and peak performance noted in those aged 30 to 39 years. So now, when it gets here, the score started dropping again. So that is basically what we are trying to see. So this is the continuation to the first side. So when you are doing ANOVA, This is a complete ANOVA test that you can add into your thesis. So you follow this format. First, you have to check if there is statistically significant difference, and if there is, then you do you find out where the differences lies. So please, if you find this video useful, like, subscribe, and turn on the notification. Very soon, more interesting analysis are to flow. Thank you for your time and have a great time. Bye.